Hotline. I'm Doris Johnson Humphrey.
And I'm Robert Vriesman. We're here for the math segment of Homework Hotline. But before we get started, let's go to one of our English teachers, Mario Suarez, at the phones and see what kind of calls are coming in now. Mario?
Robert, thank you. And Doris also.
Thank you.
The calls are coming in, and they're coming in to our dialer teachers who are here ready to answer and help you with your English and math questions. The phones are getting busy today. We've got 15 lines and 15, count them, dialer teachers to take your calls. So call now. And if you have an English question, call for me and ask for me, and maybe we can do your problem live on the air. The English comes on at 5:10. So stay tuned now for 40 minutes of math with Doris and Robert. Math away.
Thank you. Remember, you can call in your questions simply by calling, and we're going to give you the number in just a minute. But go get yourself some paper, grab a couple of sharpened pencils, sit down, write down the problems that we're doing, involve yourself in the activity, because math is not a spectator sport. You get better at it by practicing it.
Great. Right.
Doris, what are you going to do today?
Well, today I have a problem dealing with slope-intercept, simplifying polynomials, equations, and factoring.
And I'm going to do a couple systems of equations.
Great.
I'm going to solve one with elimination, another one with substitution, and I have quite a bit of help today.
Great. I have a substitution that I'm going to do also,
which is going to be a lot of substitution.
A lot of substitution today.
Okay.
Remember, you can reach us by dialing 1-800-527-8839.
Or just dial 1-800-LA-STUDY. The call is free, the help is free, so what are you waiting for?
Great.
You're first.
Thank you. My first question, I'm going to be working with Taisha.
Yes.
Okay, great. You have a nice, strong voice, Taisha. And here's the problem that we're going to be working together. Y squared minus the quantity y minus 1 to the second power. Before we get into that particular question, Taisha, let's go back and do a little review. Have you worked problems like this before and you were asked to factor them? A squared minus b squared. Have you seen anything like that before?
Yes.
Okay. There's a unique way that we factor an expression like this. And what kind of factoring is this called? Let me give you a little hint. The difference of squares, because here we have a square, and our minus sign represents a difference. So this factoring is called the difference of squares. In this instance, the difference of two squares. And there's a certain way that we factor that. We're going to end up with two binomials. Here, we're going to take the square root of our first term. And what is the square root of a squared? Taisha?
Uh-huh.
The square root of a squared.
A.
Great. And so we'll put a here and a there. Same thing in each parenthesis. And the square root of b squared
Is B.
b, and we'll put a b here and a b here. And now we're concerned about the signs that go in each parenthesis. We'll know that one of the signs is going to be what?
Plus.
Okay, and the other is going to be?
Minus.
Minus. And the reason that is because if we have a negative sign here, the only way that we can get a negative sign when we multiply is that one has to be positive and one has to be negative. Okay, so let's walk through that again. We have difference of squares. This is a perfect square. This is a perfect square. We take the square root of the first perfect square. We take the square root of the second perfect square, and one of them we put a plus sign and the other we put a negative sign. Okay, you understand that?
Yes.
This particular problem is the exact same kind of problem. However, you'll notice that here we have y squared, and here we have a binomial, but it's still a term that's squared. So when we factor that, we're going to use the same method, okay?
Yes.
So now let's move to your problem. I'm going to put brackets this time. Now, we're going to take the square root of y squared, and what is the square root of y squared?
Y.
Y. Same thing. This time, instead of having a b, we have a binomial. What's the square root of y minus 1?
Y.
Remember before when we had that b, it was the square root of it was 1b in each parenthesis. We have two of these y minus 1s. So what's the square root of 2y minus 1? Is what? So really what you're looking at, you have y minus 1, and we have y minus 1.
Oh, 1.
So it's going to be y minus 1, y minus 1. Remember what we did when we had the b? Really, when we had the b before, we had b squared, and that was b times b, so 1b went in the first, 1b went in the second. So the square root of a term is always one of those. Okay? You follow what I'm saying?
Yes.
Okay? It'll come clear in a moment. So that's what happened. So we took the square root of our y and the square root of y minus 1, which is a whole unit, y minus 1, y minus 1. Before you told me that in the first set of parentheses we put what?
Y.
What kind of sign did we put?
Oh, minus.
Okay, we can put a minus there. We put a minus there, so what happens here?
Plus.
Plus, because the positive times the negative gives us this minus sign between our two terms. With this particular problem, because we had a binomial, we're going to have to simplify now. So what we have is y minus, this negative tells us that the signs inside are going to change, right? So this y becomes a negative, and I'm going to circle that. This becomes positive, and now we are adding, okay?
Yes.
So now let's complete the simplifying of this. Y plus negative y gives us what?
A positive. Y.
Y negative y. What happens? When we add a positive and a negative and they're the same thing, they cancel out, right?
Yes.
So y, what we're looking at is y minus y gives us 0. Okay, so those cancel out, and here we're left with, see, the y's canceled, and we're left with what?
1.
1. So out of this, when we simplify all of that, all we're left with is 1. Now let's move over here and see what happens. This time we have y plus y, and what does that give us?
Y to the second power.
You're not multiplying, Taisha, we're adding. We have a 1y plus 1y, and that gives us
Y.
y
Plus 1.
plus y, and we're adding this. What do we get? 1y plus 1y gives us,
Y.
right? Okay,
Yes.
so 1y plus 1y gives us 2y. Remember, we're adding, not multiplying. Okay, so we get 2y. We have 2y, and then we have a negative 1, and we bring that down. So now when we simplify here, what do we end up with here?
2y minus 1.
2y minus 1, and now we're multiplying 1 times 2y minus 1. So our final answer, we don't have to put the 1 there, so our final answer is 2y minus 1. Okay? Again, this was similar to what we did with the a squared minus b squared, but whenever one of your terms is a binomial, that binomial doesn't change, it just becomes a factor in each of your parentheses, okay?
Yes.
So you need to work some more on those kinds of problems, because this kind of factoring comes up a lot. So if you have a book and you were doing homework, try to see if you can do some more differences of squares, and if you have any trouble, call 1-800-LA-STUDY, and the dialer teachers will be able to walk you through some more problems, okay?
Okay.
Okay, thank you for calling. Bye.
Thank you.
You're welcome. Let's move over to the next question, which was a question called in by Mike, who's a 9th grader. And here's an equation that we're going to graph. 2x minus 3y equals negative 6. In order to graph this, we're going to put this in slope-intercept form, which is y equals mx plus b. And here the m represents your slope, and the b represents your y-intercept. And the y-intercept tells us at what point the graph is going to cross that y-axis. So let's put this in that form. So we have negative 3y, and we're going to subtract 2x from both sides, which gives us negative 2x, negative 6. The y has to be without a numerical coefficient, or numerical coefficient of 1. So we're going to go through and divide through by negative 3, which leaves us with y equals 2/3 x plus 2. And now you'll notice this represents our m, which remember is our slope, And this represents our y-intercept, which is going to tell us where our line has to cross that y-axis. In dealing with the slope, you'll notice here we have 2/3 x. The number on the top represents the movement on the y-axis, and the number on the bottom represents the movement on the x-axis. So starting at our y-intercept, which is 2, we're going to put a dot there. If I move 2 in the positive direction on x, on y, I move over 3 on x, and that gives me a dot. Now we can also do a negative. As long as we go negative on x and negative on y, it still gives us that positive slope of 2/3. So I'm going to use my negative this time. 1, 2, I went 2 negative on y, so I'm going to have to go 3 negative on x, which gives me that positive. And you'll notice we have our 3 points. If you draw your line through your 3 points, this particular graph represents 2x minus 3y equals -6. Remember, m and y are critical when you are graphing your line, your linear equation on a graph using this particular formula. Okay, the next question is a system of equations that was called in by Anna, and we're going to solve this by the method called substitution. We have 2 linear equations, and we're trying to find the value of u and z, where if we were to graph these 2 equations on a line, the dot that's common to both of those would be shown on this particular graph. So let's move on with this. I'm going to look at my first equation, and I'm going to rewrite that in terms of u. So let me pull this down. I'm going to solve for u, which means I have 2u. And again, I'm going to be subtracting 2z from both sides. And that gives me 2u equals -2z plus 8. Let's go through and divide through by 2. And I have u equals -z plus 4. Now what this represents is my value that I'm then going to go back and plug into my equation wherever I have u. So I'm going to use my second equation, 5u minus 3z equals 4. And this represents u, and this is the value now that we're going to put in to represent our u. So we have -z plus 4. In simplifying, we have -5z plus 20 minus 3z equals 4. Simplifying here, we can simplify our z terms, which give us -8z plus 20 equals 4. Subtracting 20 from both sides, we get -8z equals -16. Dividing, we have z equals 2. Now we have a value for z, which is 2. Let's go back here where we solved for u and just substitute that value in that we got for z. So we now have u equals -2 plus 4. Simplifying, combining, we have u equals 2. So now we have our ordered pair, which is 2, 2. The value for u is 2, the value for z is 2. Let's quickly check this back into our equation. Remember, u and z are both 2, so 2 times 2 gives us a 4, plus 2 times 2, 4, 4 plus 4 gives us 8. That checked, and let's just check it in our second equation. 5 times 2 is 10, minus 3 times 2, which is 6, so 10 minus 6 gives us 4. This works out to be our answer and our ordered pair and our solution set, and we can just put it into braces. Over to the next problem. Problem called in by Dana, and we're going to be dealing with simplifying radicals. First of all, under the radical, we have to try to see if we have any perfect square factors under that, because we can't leave any perfect square factors under the radical sign. So here I'm going to rewrite that so that one of my factors is a perfect square, and that'll be 16 times 3 gives me the 48, and 16 is a perfect square. For 75, I can have 3 times 25 because that's a perfect square. And for 192, 3 times 64, and 64 is my perfect square. So we're trying to make sure that we have one perfect square factor under the radical that we can extract the square root. So now we have 1/2 already outside the radical. If I take the square root of 16, which is 4, that comes outside the radical, and under the radical, we're left with a 3. Here, we have a -3 outside the radical. 25 is a perfect square. The square root is 5. That comes out of the radical, and we're left with 3 under the radical. Here we have -3/4 outside the radical. 64 is a perfect square. The square root is 8. That comes out and we multiply it, and what's left under the radical is radical 3. At this point, you see that we have the same radical, so we're going to be able to combine these. So let's finish the multiplying from outside. Here gives us 1/2 times 4, which is 2 radical 3. This gives us -15 radical 3. And this we can simplify. This gives us -6 radical 3. Again, because we have like radicands, we can add. So we have 2 minus 15 minus 6 all times radical 3. Combining here, we have -21, 2, which gives us -19 radical 3. So the important thing when you're dealing with radicals is to try to get the greatest perfect square factor that you can. So you really have to know those perfect squares very, very well. And as you simplify, we end up with the answer to that particular question. Let's move on. Remember, whenever you're dealing with equations, you're always trying to solve for that variable. So the first thing we would do here is to subtract 5 from both sides, which gives us 4x equals 1. Dividing both sides by 4, we get x equals 1/4. Once you get the value, always try to go back into your equation and check it in. So 4 times 1/4 would give us 1 plus 5 equals 6, and it checks, and so automatically you know that your answer is correct. That ends the math segment for me today, but stay tuned for Robert with 15 more minutes of math.
Thank you, Doris. I'm going to be dealing with a couple linear equations. We call this a system of equations. Both of these equations represent lines on a graph. It's kind of like that's their name. It's the name of these lines. But before I get started, I have some help, and I'd like to introduce to everybody Janaea. Janaea, are you there?
Yes.
Oh, good. You're coming through loud and clear. So this, can you see the problem on the board? The camera will zoom in just a second. Can you see it okay, Janaea?
Yes.
Okay, good. Now, we're going to use a process called elimination. We're going to try and eliminate one of the variables, either the x's or the y's. Janaea, what do you suggest that we eliminate?
The x's.
The x's. And why do you suggest that?
Because it's a lot easier.
It's a lot easier. She's right. If we tried to eliminate the y's, we would have to multiply the top equation through by 2 and the bottom equation through by 3. So we'd have to multiply both equations. But if we choose to eliminate the x's, then we only have to multiply the bottom one through by -2. So Janaea, let me rewrite the top equation, and then you tell me what to write for the bottom equation. Okay, so let's multiply through.
-2x.
-2x.
Plus 4y.
Plus 4y. Why is it plus 4y?
Because you're multiplying a negative.
Negative times a negative. Very good. Equals?
Equals -28.
-28. Okay. Now we can add. Some people call this the addition or subtraction method because what we're going to do is add and eliminate the x's in this case. So right here, these are gone, right, Janaea?
Right.
You add the rest of it for me.
7y equals -14.
-14. Because we have a positive 14 and a -28. Now what do we do, Janaea?
Divide each side by 7.
Right. Why do we divide by 7?
Because we're trying to get the y by itself.
That's right. We divide because the y is being multiplied by 7. So in order to undo that, we divide it by 7. And we have to do it to the other side as well. So the 7's cancel out here. And what is y going to equal, Janaea?
-2.
-2. Very good. Now, are we finished?
No.
No. We're only halfway through the problem. So now we can plug this -2 in for the y. At this point, it becomes a substitution problem, right?
Right.
At this point, we're substituting the -2 in for the y. So let's rewrite this equation, and I'll leave the parentheses for the y here. X minus 2, there's my parentheses for this y, equals 14. I stick the negative 2 in there. Now you tell me what to write, Janaea.
X plus 4
Plus 4, that's right, because negative 2 times negative 2 is going to give me this positive 4.
equals 14.
Okay, very good. Janaea, you sound like a pro. Are you nervous?
Yeah, a little bit.
Well, you're just doing an excellent job. I mean, you could come here and take over this show very easily. Okay, now what do I do?
You subtract 4 from both sides.
Subtract 4 from both sides. Will it bother you if I just write x equals 10?
No.
Okay, good. We don't always have to show that. Once we get to a point where we can see the obvious things, we want to pick up some time-saving techniques. And so the easier things, and once you've practiced it a lot and you know exactly what you're doing, you can just write x equals 10. Are we finished now?
No. You have to...
Okay, well, we should write it as an ordered pair, right?
Right.
Okay, which coordinate always comes first?
X.
The x, okay? Let's write it up here. So we'll write 10, comma,
Negative 2.
negative 2. Now, Janaea, can you tell me what it is that this actually represents?
It is the intersection of the two lines.
It's the intersection of the two lines. Very good. It is the point on a Cartesian coordinate system, which we commonly refer to just as a graph, where these two lines meet. Janaea, that was very good. Would you help me with the substitution problem?
Yes.
Okay, great. What should we do first here? Can you see the problem okay?
Yep.
Okay, great. What should we do first?
You want to find what x equals?
All right. We could subtract either x or y from both sides, but as you suggested, let's subtract a y from both sides. All right? You tell me what to write.
X equals 4 minus y.
Okay, 4 minus y. Now, could we write that another way?
Yes.
We could also write that how?
Negative y
Negative y
plus 4.
plus 4, okay? It doesn't really matter. We can use either one of those. But one of the things we want to demonstrate here is that the commutative property is working here. This is a positive 4. It doesn't matter if we say negative y plus 4 or if we say 4 minus y. It's exactly the same thing. All we have done is switch the terms. It is no different from saying 3 plus 4 equals 7 or 4 plus 3 equals 7. They both equal 7. It doesn't matter. Addition is commutative. All right, now we know, as Doris pointed out in her segment of the show, we have found the value for x. This expression right here is just as good as the x. All right, if we're talking about a football game and x was the quarterback, we could pull x out because he got hurt and put in negative y plus 4 and the game would continue. Right, Janaea?
Right.
Okay, so now let's rewrite this top equation and leave a parentheses for the x. Okay, 5, a set of parentheses for the x, plus y equals 20. All right, now, what can I put in that blank there?
Negative y plus 4.
Negative y plus 4, all right? Now you tell me what to write, Janaea.
Negative 5y
Negative 5y
plus 20.
plus 4. Oh, plus 20, I'm sorry. My mind just went a million miles away. Okay, negative 5y plus 20
Plus y
plus y
equals 20.
equals 20, all right. Now let's combine our like terms.
Negative 4y
Negative 4y
equals 0.
equals 0. Ah, out there in the audience, can you see what Janaea did? She combined a couple steps into one. She already saw that she's going to have to subtract 20 from this side, so she went ahead and subtracted it from this side as well. She saw by inspection that this was going to have to equal 0. Okay, very good. Now what do we do, Janaea?
You subtract negative 4.
No, we don't want to subtract because we have multiple...
I mean divide.
Right. We want to divide both sides by negative 4. All right. Now, these negative 4s will cancel, so y is going to equal?
0.
0. Right. You know, it's something about a fraction that has 0 in the numerator that freaks some people out. 0 divided by some number is always going to be 0. Now, what we do have to be careful for, it's not in this problem, but I do want to mention, what if we had something like this? Janaea, do you know what that is called? Say it. You're close. Go ahead, say it.
Undefined.
Undefined, that's right. Because we cannot divide anything by 0. We cannot divide by 0. But sometimes I think we confuse this for this. this is no good or this is undefined, but this is perfectly possible. I mean, if you have no money, you can divide it evenly amongst all your friends. They all get no money, okay? So 0 divided by something is still going to be 0. Now, are we finished?
No.
No, we still have to solve for the x coordinate. But I believe we can also do that by inspection. If we can get the camera to pan back up here, if the y is 0 and the sum is 4, what does the x have to be, Janaea?
4.
It has to be 4. Okay, very good. And we want to write that as an ordered pair, 4, 0. And Janaea, do you want to remind everybody once again what this actually represents?
It's the intersection of 2 lines.
It's the intersection of the 2 lines. Very good. If we were to graph these 2 lines, they would intersect at this point, 4, 0. Janaea, you did a terrific job. Let's have a round of applause for Janaea. Listen to that. Ah! Excellent. Excellent job, Janaea. Thank you very much.
Okay, bye.
Bye-bye. All right. Now I'm going to move on to a couple other problems here. And I think I also have some help with these. Victoria, can you hear me okay?
Yes.
Great. Oh, you sound like you're really excited to do this. Okay, your name is in print, your name is in lights, you're going to be famous. So help me solve this problem here, all right?
Okay.
First of all, let me ask you, Victoria, what factors do those 2 terms in the numerator have in common?
12 mx.
12 mx, that's right. I'm going to write that down here. There's a factor of 12 in both of these terms. There's a factor of m, and there's a factor of x. So those are the common factors. When we say factors, don't forget, the definition of a factor are 2 or more things that can be multiplied together to form a product. Now, it doesn't always have to be a number. Sometimes it's a variable that represents some value. So in this case, it was a 12, an m, and an x. All right, now, Victoria, can you divide both of those terms by that common factor and tell me what you would get?
1 plus y.
1 plus y. And let's talk a little bit where we got that, all right?
Okay.
All right. Now, if we put 12mx over 12mx, what do we get? Anytime we divide something by itself, we always get
1.
1. That's right. So those people that are wondering where this 1 came from, if you divide this by this, you get 1. So that's why we wrote it right there. Doris, I don't have any eraser. Oh, thanks. All right. So let's get rid of this. Now, likewise on this last part, 12mxy divided by 12mx. The 12s can cancel, the m's can cancel, the x's can cancel, and I want to remind everybody that canceling is just a form of division. All we're doing is dividing down to 1. 12 divided by 12 is 1, m divided by m is 1, x divided by x is 1, 1 times 1 times 1 is 1, and 1 times y is?
Y.
Y. Okay. Why? Because, oh, no, I guess that's Disney. Okay. Now, we still have a denominator here that's 12mx. Now, what can we do, Victoria?
You're going to cancel the 12mx in the numerator and the denominator.
Okay, excellent. These both cancel right here, and we're left with 1 plus y. Can we do anything else with it?
No.
No, that happens to be the answer. We have simplified it as far as we could go. All right, Victoria, let's move over to this next one. It looks a little more complicated, doesn't it?
Yeah.
This type of thing, for some reason, it looks like junior high school students or middle school students just shouldn't be capable of doing this. But it turns out to be a relatively easy problem when we get all finished. Now, first of all, let's combine as many factors in the numerator as we can, all right?
Okay.
All right, how many factors of x are there altogether, Victoria?
X to the 7th.
X to the 7th. And let's see if we can find out where Victoria got all those factors. There was 2 here, there's 1 here. If there is no exponent, we know that it's just 1 factor. And 4 here, 4, 5, 6, 7. Okay, Victoria is absolutely correct. It's x to the 7th. Okay, now, what can we do with that y to the negative 2 in the parentheses that is squared?
You're going to make it y to the negative 4th.
That's exactly right. Y to the negative 4. All we do is we multiply these 2 terms together. Okay, we don't add them together because we're not multiplying two things of a similar base. We are multiplying y to the negative 2 times y to the negative 2. All right? Let's take another look and see why that works. Okay, do you have the time to go into this a minute?
Yes.
All right. Y to the negative 2 times y to the negative 2. That's the same thing as y to the negative 2 squared, isn't it?
Yeah.
Okay, so if we did it the long way, then we would get, this would also equal y to the negative 4. In this case, we added these two exponents. So it also makes sense that it would work if we multiplied 2 times negative 4, we would still get y to the negative 4. All right?
Yeah.
Okay, good. So, you know, it turns out that there's no real magic in mathematics. What the beautiful thing about mathematics is that as we go through, we see that it all fits together in a very logical sort of way. And it's just a huge puzzle that we have an opportunity to figure out. I like to think of it as the art of mathematics. Okay? Okay. Now, what's the next thing that we need to do?
Well, the p to the 0 power times the 2 exponent is going to make 1.
Okay, very good. All right. We know that anything to the 0 power is 1. Anything to the 0 power is 1. So if we have 1 squared, that just is 1 times 1, and that also equals
1.
1. Okay, good. But we already have something in our numerator, and if we multiply 1 times this, we still get this. Right, okay. So we don't need that 1 anymore, so we can just kind of get rid of that altogether. So we have 7 factors of x, and we have y to the negative 4. Now let's jump down to the denominator there, and this 2, this exponent of 2 is going to affect everything inside that parentheses. So Victoria, you tell me what to write.
X to the negative 6.
X to the negative 6th.
Y to the negative 4th.
Y to the negative 4.
And then just y.
And we still have that y, all right? Now, from this point, there's a couple ways we can proceed. A lot of algebra teachers like you to use subtraction. In other words, we could go 7 minus a negative 6 or negative 4 minus a negative 4. But I like to change them to positive to exponents, since it's not too hard to do. But so anything that's a negative exponent in the numerator, let's put it in the denominator and make it positive, and do the same thing with the denominator. Can you do that?
Yes.
All right, tell me what to write.
X to the 7th.
That's the one that's already there.
X to the 6th.
Then you pulled this one from down here up here. That's good.
Y to the 4th.
Y to the 4th, so that's this one down here moving up here. Over, good.
Y to the 4th, because you're bringing it down to the denominator.
Okay, so this one is coming down here, all right? I'm going to write it underneath this other one.
And then y.
And then we have this other y, all right. Now we look to see if we can cancel terms and combine our other factors. Can you tell me what to write in the next step?
You're going to cancel the y to the 4th,
Right.
the numerator, and the y to the 4th in the denominator.
Right. Now, I'd like to point out at this time that we could have canceled it up here. As long as it's the same exponent and the same base, we could have canceled it up here, which would have been perfectly fine. But it's not a mistake. It's just a different little road we could have taken in the course of solving this problem. And now what do we do, Victoria?
You're going to add the x's in the numerator, which you're going to get x to the 13th.
X to the 13th, right. What we're doing there is we're multiplying these two bases. But when we multiply two factors that have a similar base, we add their exponents, and that's where Victoria got the x to the 13th. And then what else is left there?
You're going to put x to the 13th over y.
Over y. All right. Victoria, you did a super job. You have a great future ahead of you in mathematics. And listen to that applause. The audience is terrifically excited about your future. Thank you very much, Victoria.
Thank you.
All right. You did really a terrific job. Call again.
Okay, thank you very much.
You're welcome. Bye-bye.
Bye-bye.
All right. Well, it looks like we have a board full there. I always hate to erase that work because it looks so beautiful. But I do have a couple more problems here. I have some by Francisco called in yesterday. He's a 6th grader at Muir Elementary, and he wanted to see some mixed numbers subtracted from some whole numbers. So I have plenty of time to do several of those. But I always hate to erase my good work, though. All that work, and then it just goes up in chalk dust. So, all right. So what Francisco wanted to see is something like this: 5 minus 3 and 5/7. All right? The first thing that I would like to do in a situation like this is I want to rewrite that so it's in an algorithm that's a little bit easier for us to work with. So I'm going to write the 5 like this: minus 3 and 5/7, and write it like that. Now, there's no fraction above that 5/7, and I desperately need a fraction above that 5/7 if I'm going to subtract anything from it. But there's nothing there. So I have to go to the neighbor over here, and I have to borrow one. So I borrow one, and he's left with 4. But what I like to do in my class is I like to write that 1 down so we can see that it still exists. The 5 is still there. There's the 4, there's the 1. Together that makes the 5. But I can't just put a 1 right there, but I can change that 1 into a fraction. I'm going to change that 1 into 7/7. Remember, anything divided by itself is going to equal 1. But why did I choose 7/7? Well, because I have 7ths here. I have 7ths. So then I'm going to put 7/7 right here. And again, I want to remind you that 4 and 7/7 is the same thing as 5. It's like taking a $5 bill, getting change, get 4 $1 bills and 4 quarters. Only in this case, it happens to be 7ths instead of quarters. Now I can take 5/7 away from 7/7, and I can just have 2 7ths. 4 minus 3 is 1. Okay, now I just have 30 seconds, so I'm going to squeeze one more quick problem in there for Francisco. All right, so let's pick 3 minus 1, and let's see, what should we pick? 8/9. All right, there's a good problem. Okay, I just made this one up here. So we're going to have to borrow from the 3. That leaves 2. There's the one that we borrowed right there. We're going to get it changed into 9/9. So I'm going to put that 9/9 right there. You don't have to write that over there, but when you're first doing it, it's good to see what that 1 is. I subtract 8/9 from 1/9, and I have 1/9. 2 minus 1 is 1. I'm done for today. That's all the work that I have. But stay tuned because we have some exciting English coming right up with Mario Suarez.
Hi, welcome to the English segment of Homework Hotline. I'm Mario Suarez, but before I get to that first call, remember that the dialer teachers are here ready to answer your questions in English and math, social studies and science, and they'll be here until 7:30 this evening. Now, let's see if I have that first call. Who's on the line?
Hi, this is Angela.
Angela. Oh, Angela, this is what we're going to do. We're going to explore the rule or rules for the English plural. Aren't you excited?
Oh, yes.
And that means that we're going to be changing singular words into their plural form. But first, here's a poem to kind of stir up the pot. And look at this very carefully. We'll begin with a box, and the plural is boxes. No problem. But the plural of ox should be oxen, not oxes. Right away, we're in a little bit of difficulty. Then, one fowl is a goose, but 2 are called geese. Yet the plural of mouse should never be meese. You may find a lone mouse or a whole set of mice, yet the plural of house is houses, not heis. If the plural of man is always called men, why shouldn't the plural of pan be called pen? If I speak of a foot and you show me your feet, and I give you a boot, would a pair be called beat? If one is a tooth and a whole set are teeth, why should not the plural of booth be called beef? Then one may be that, and 3 would be those. Yet hat in the plural wouldn't be hose. And the plural of cat is cats and not coes. We speak of a brother and also of brethren. But though we say mother, we never say methrin. Then the masculine pronouns are he, his, or him. But imagine the feminine, she, shiz, and shim. So English, I fancy you all will agree, is the silliest language you ever did see. And that's our dilemma. Have you got that so far, Angela?
Yes.
Okay, now you're going to have to help me. We're going to be talking about the ambiguity, the fact that the English plural can be misunderstood. The regular English plural, we just add an S. Here it is. We have the word boy. If we want to speak of more than one, we say what?
Boys.
Boys, we add an S. If we want to say more than one pen,
Pens.
pens. If we want to say more than one book,
Books.
books. So easy. But, oh boy, English. That's great, except, and remember this except, if the word ends in a sibilant sound, an S-like sound, we add ES, not just S. Look at the word wish. How do we say more than one wish?
Wishes.
Wishes. Church.
Churches.
Churches. Kiss.
Kisses.
Kisses. Ads, which is a kind of tool.
Ads.
Ads.
As.
Good. Now we're following it. And box, of course, is
Boxes.
boxes, right?
Right.
All right. However, we do have this other problem. We have this except, and then we have some exceptions to the exceptions. We have the word monarch, which is a CH, but if we say more than one monarch, we say what at the end?
Ease.
Monarchs. Because remember, that CH is a CH, but over here it's pronounced like a what? Monarch.
Like C.
Pronounced like a K. You've got it?
Yes.
So then we just add the S. We have the word paradise, and that ends in a sibilant sound, but it's got the silent E there already, so we just add an S. Paradises. And then we have the word quiz. And remember what we did with ads. We added an ES. But with quiz, for some reason, we double up the Z and we say quizzes. Now here's a tough one. Do you think you might be a doctor?
No.
No, okay. Well, here's one of the problems that doctors have with anatomy and bones and things. Here's the word coccyx. That's the tailbone. And when the doctor has to say the plural for that, it would be nice if he could just add an ES as in box, boxes, but he doesn't. He has to say coxages. He has to, I don't know if you can see that, but you drop the X and you make a GEX, coxages. My goodness, but we're not through yet. Except, another exception, if the word ends in SIS, we drop the Y and add an E. Do you know what an oasis is?
Oasis.
It's a garden spot with water in the middle of the desert. And if we want to speak of more than one oasis, we drop that I and you make it an E, oases. We have a basis, a foundation. More than one would be bases. A crisis, you hear this on the news all the time, there's a crisis in the Middle East. More than one would be crises. Hypothesis in math. One is hypothesis and the plural would be hypotheses. And when you're writing a paper, you may be writing a thesis paper and the plural would be theses. So that's an exception also. And that's not the end. Then we get to the original English words that we had in the language from over 2,000 years ago. We have the word man, and how do we make that plural?
Men.
Men. For some reason, we go like that. With woman, that becomes what?
Women.
Women. And notice that with women, we also do something to the pronunciation here, don't we?
Right.
The singular is woman, and the plural is women. So we do two things there. What's the plural of child?
Children.
Children. Okay, that's the old plural. What's the plural of ox?
Oxen.
Oxen. Oh, you're right on target. What's the plural of tooth?
Teeth.
Teeth. Brother.
Brothers.
Well, brothers is great, but then in church and in the Bible, it's brethren. Have you heard that one?
Not yet.
Yes. Then we have foot becomes feet, mouse becomes
Mice.
mice, louse.
Oh, I haven't heard that one either.
Okay, it's a good thing. Louse, the little critter, becomes lice. However, if you call someone a louse and you happen to see two of them, they would be louses, okay?
Okay.
Goose becomes
Geese.
Geese. However, dormouse, have you ever read Alice in Wonderland?
No.
The dormouse keeps falling into his cup of tea. If there's more than one, it becomes dormice. Then look at the word mongoose. Remember, goose becomes geese. Mongoose, is a mongoose a bird? No, it's a completely different critter. And the mongoose is the one creature that's not afraid of that cobra. And he lives in India. And the plural, you would think because of this ending here, goose and goose, it would be mongoose, but it isn't. It's just a coincidence. So you say mongooses. Look at this treacherous ground that we're going through. Now look at these pronouns. You can help me on this. The plural of I becomes what? I go to the store. My friends and I, we.
Oh,
We go to the store. Very good. You. And what's the plural of you? If you're talking to one of your friends, you say you. If you're talking to two of your friends, what do you say? You again. Same thing, right?
Oh, yeah.
Yeah. Oh, we're in English now, Angela. He and she, what's the plural?
They.
They. Now we're on track. Now what about the we? We over here is the plural, you is the plural, and then him, her, the plural there would be them, right? Okay, good. Now, we still going on. Are you with me so far?
Yes.
Okay. If the word ends in a consonant plus a Y, you drop the Y and add IES. You're very familiar with that. You have the word city. How do you make the plural?
Cities.
Cities. Drop that Y, IES. You have the flower, the lily. What do you do?
Lilies.
Lilies. Country. Same thing, right? No problem. However, what do you do with a proper name? You have a consonant R and you have a Y. The plural there is simply an S because you want to keep the integrity of the name. Lily here, that's a name, is different from Lily the flower. We just add an S. And you talk about a Smith and you talk about two Smiths and you just add an S. So again, another exception to the exception to the exception. We're going to go on. If the word ends in a vowel plus the Y, you add an S. Valley. How do you make that plural? Valley.
Add an S.
Add an S because it's a consonant. Foray is a raid. What would you do with that one? It's a vowel and a Y. You just
Add an S.
add an S. Monkey. One monkey, 10.
Add an S.
10 monkeys, you add an S. However, we have an exception. Look at the word money. If you talk about the money of England, the money of France, the money of Germany, the plural there would be monies. You drop the EY and you make it IES. Very confusing. Let's go on. If the word ends with a UY, where the U is pronounced like a W, you drop the Y and add IES. We have this word soliloquy. Have you read Romeo and Juliet or Midsummer Night's Dream yet? Not yet, right?
Not yet.
Okay, you have a lot to look forward to. In those plays, they will have a soliloquy where someone is on stage all alone and he speaks his mind. The plural there is, you drop that Y and add IES. A colloquy is a conversation. Look at all these words we're learning. You drop the Y and IES. The U is a vowel, but it's pronounced like a W. Look at this now. For about a dozen words ending in F or FE, you change the F to a V and add ES. What's the plural of calf?
Calves.
Calves, look at that, VES. Thief.
Thieves.
Thieves, VES. Wife.
Wives.
Wives. Wolf.
Wolves.
Wolves. Leaf.
Leaves.
Leaves. Wharf.
Wharves.
Wharves. Good. Knife.
Knife.
Knives. Life.
Lives.
Lives. I should say life there. Life becomes lives. However, we have an exception. What do we do with the word roof?
Just add an S.
You just add an S. It's you shouldn't because look at all these F's here, right?
Right.
And cuff, you add an S also. I couldn't trick you on that one. Now let's see what I do here. What happens with a compound word? An editor-in-chief of a newspaper. What do we do there? How do we make that plural?
Editors.
Editors. Because you add the S to the root word. The main word there is editor, not in and not chief. What do you do with sister-in-law if you have more than one?
Sisters.
Sisters-in-law. And a court-martial is?
Courts.
Courts martial, a military court. Okay, now you're still with me on this. Okay. Words ending in O generally add S. What do we do with the word radio?
Radios.
Radios. Dynamo.
Dynamos.
Rodeo.
Rodeos.
But some of them you add ES. Echoes becomes what?
Echoes.
Echoes. Echo, echoes. Halo.
Halos.
Halos, ES. Potato.
Potatoes.
Potatoes, ES. Tomato.
Tomatoes.
I'm getting hungry. Okay. Hero becomes
Heroes.
ES. And here's a tricky one. What about the word no?
Just add an S.
You add what?
An S.
Oh. You add what? An
ES?
ES. An ES. In other words, if someone's taking a vote and they say there are 10 yeses and 10 nos, you would add ES to no. Okay?
Oh, okay.
All right. We're still going. What do you do with symbols? Here's a symbol. It stands for number. How do you say that there are 10 of these? You add? Apostrophe S. Oh, good. A number. There are 10 fours in the equation.
Apostrophe S.
Apostrophe S. There are 10 letter A's.
Apostrophe S.
There are 10 words and
Apostrophe S.
apostrophe S. Look at all these plurals, my goodness. And then there are certain words that are singular in meaning, but they look plural. News. What is the news? That looks plural, but it's singular. You don't talk about a new. Mumps. If someone has the mumps, it's singular, but it looks plural. If he just has a slight case of it, you don't say he has the mump, right? Okay. Measles, the same thing. Smallpox. Mathematics. Okay. Then we go on. Words that are the same in singular and plural. If you catch one fish or 10 fish, the same thing.
Yeah.
Sheep, 1 sheep, 10 sheep. 1 trout, 10 trout. 10 deer. 10 Japanese, 10 Chinese, 10 cattle, 10 Siamese, 10 Vietnamese, 10 series, 10 species, 10 vermin, critters, and 10 swine, all the same. These are words that are the same in the singular and the plural. But we're still going on. Words that are in the plural only. And here's a tricky one. Most people can't pronounce it. This word means food, and you pronounce it victuals. Victuals, food. And it's in the plural only. If someone is on a diet, they don't have a victual, they're still having victuals. If suds, if you have a washing machine and you ran out of soap and you just have a little bit, you don't say that you only have a sud. Thanks. If someone has done you a favor, but it's not a big favor, you don't talk about a thank. Clothes, the same way. Pliers, pants, tweezers, and scissors. All of those words. Now, let's go over here and we'll finish up with certain words that we get from foreign languages. And here's what we have. We talk about a stimulus and the plural. Do you happen to know what that is?
Stimuli.
Stimuli. Oh, Angela.
Yes.
Angela, very good. Stimuli. Fungus.
Fungi.
Fun.
Jai.
Fun.
Jai.
Here's a tricky one. The G changes pronunciation. Fungi.
Okay.
Remember what we did with another word like that. Woman became women. We changed that pronunciation also. A focus. Do you know what the plural of that is?
No.
That's tricky. That's foci.
Oh.
Foci, that's the plural. Radius, you know this one.
No, I don't.
Oh, sure you do. Radii.
Oh.
Sure you do. Radii. Radii. Alumnus.
Alumni.
Alumni, very good. Now here's a very tricky one. The alumnus is the male, the boy. The alumna is the girl. What's the plural?
Is it the same thing?
No. We want to give her something different. Alumni.
Oh.
Now, a lot of people don't know that, so they cheat. And they only talk about alums. See how they cheat? We have larva. Do you take science? What's the plural?
Larvae.
Larvae. Oh, good. We're rolling. Alga becomes
Al.
Look what we did with fungus.
Algae.
Algae. Very good. The soft G. Formula becomes,
Formula.
we can either add an S, or if we want to get very, very technical, we say formulae.
Okay.
Formulae. Antenna. This is a curious one.
Antennae.
Antennae, good. Now that's a good example. Antennae, if you're interested in bugs and their antennae. But if you're talking about television, you just simply add an S, antennas.
Okay.
Medium becomes, what's that word that we always use referring to newspapers and television, etc.?
Media.
Media. Oh, Angela, that's super. Super. Memorandum becomes what?
Memoranda.
Memoranda. And again, people cheat. They'll simply talk about a memo or memos. See how people get around that? Datum becomes, what is that information you feed into a computer?
Data.
Data. Data. And phenomenon becomes?
Phenomena.
Phenomena. Criterion becomes?
Criteria.
Criteria. Oh, excellent. Index becomes?
Oh boy.
You know that bit of information at the back of the book?
Yes.
Indexes.
Oh yeah.
Indexes. And a boyfriend is a beau, and we sometimes use the French plural beau with an X, and sometimes we just add the English S. Okay, Angela, that was super.
Thank you.
My time is up, but remember, you call again, okay?
Okay.
All right. Now, the rest of you, remember that teachers are still here. They'll be here until 7:30, so call up with your questions. Later.